Good afternoon, class. We are looking at pre-calculus chapter 3, polynomials and rational functions. Here's 3.1 to 3.2, power functions, polynomial functions, and their graphs. So we're going to cover power functions, polynomial functions, and graphs, dividing and real zeros of polynomial functions, complex zeros of polynomial functions, rational functions, inverse, and radical functions. The objectives of the section: identify power functions and their end behavior, identify polynomial functions and their degree and leading coefficient, recognize characteristics of graphs of polynomial functions, use factoring to find zeros of polynomial functions, identify zeros and their multiplicities, determine end behavior, understand the relationship between degree and turning points and graph polynomial functions, use the intermediate value theorem, short IVT, reminding you of what we have done: rectangular coordinate system, various quadrants, various forms of lines from standard form to slope intercept form to point slope, vertical line versus horizontal line, definition of a slope, rise over run, parallel lines that have equal slopes and perpendicular lines that have slopes that are negative reciprocal of each other. So this is the synopsis of what you need to know, okay? All right, so properties of linear functions and linear models are as follows. When you have a graph, a curve, you connect 2 points. That blue line is known as a secant line, so average rate of change, where the difference quotient, delta y over delta x, is f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1, is called the average rate of change of y, or f of x with respect to x, over the interval of x sub 1 to x sub 2, and can be interpreted as the slope of a secant line, the blue line. Various ways of writing it: rise over run. You may use this one, f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. You may use f of b minus f of a over b minus a. Or if you call this a and then the distance h, that's the run. F of a plus h minus a is the rise. That's what you have. Linear functions have the formula f of x equals mx plus b, with the slope being m, y-intercept of 0b, domain is all real numbers. The range depends if, for example, you have a horizontal line, the range is 1 point, otherwise it's all real numbers. So f of x equals mx plus b, it becomes increasing when m is positive, decreasing when it's negative, and constant when m is 0. Quadratic functions are in the form, is a function that can be written in the form of f of x equals ax squared plus bx plus c. And of course, a, b, c are real numbers. A can't be 0 for it to be a quadratic function, meaning of degree 2. So f of x equals a times x minus h quantity squared plus k is a parabola that is in the vertex form, and you can see the vertex located at h comma k. However, if it's in this format, you can calculate x equals minus b over 2a, and then plug in, and f of minus b over 2a would be the y coordinate. This is the h, this is the k. If you work it out, you can end up with this, of course. A is positive, the parabola opens up. Negative, the parabola opens down. Axis of symmetry, a line that divides a graph into two symmetrical halves. X equals minus b over 2a. X-intercept, you set y or f of x equal to 0. Y-intercept, you set x equal to 0. And from here you get 0, c. Domain is all real numbers. And as you can see, this and this one are called the vertex. Now, section 3.1, polynomial functions and models. Polynomial functions are in the form of p of x equals a sub n x to the power of n plus a sub n minus 1 x to the power of n minus 1, and goes all the way to a sub 2 x sub x to the power of 2 plus a sub 1 x plus a sub 0. This is the constant. This is a number. N is the degree. A sub n, the leading coefficient, cannot be 0. N is a whole number. That is the restriction for it to be a polynomial. Whole number is 0, 1, 2 to infinity. Domain for all of them is negative to positive infinity. Leading coefficient a sub n, again, I emphasize that cannot be 0 if you want it to be degree n. The degree of the polynomial is n. Graph is smooth and continuous. A polynomial of degree 1 or a linear function, p of x equals mx plus b, it's a linear function. A polynomial of degree 2, p of x equals ax squared plus bx plus c, is a quadratic function. In other words, we are already familiar with polynomials. And a warm-up example, what would be the degree here? P of x is 2, x to the power of 6 minus x to the power of 4 plus 2 over 5, x cubed minus 2. This is the leading term. The degree is the exponent on that, which is 6. So again, terminology. This is the leading term. Okay, leading term. And number 2, by the way, is called leading coefficient. Leading term, leading coefficient. Is the function a polynomial? If so, what is the degree? Let's look at this one. You have to really put it in descending order, you notice this is the one with the highest exponent. All the exponents are whole numbers. The answer is yes, the degree is 8. No, it's a rational function. Rational function is a function which is a fractional form. At the top and the bottom are both polynomials. Yes, degree 0. H of x equals 5. A constant is considered a linear function. The degree is 0 because you can write this as 5 x to the power of 0. This is not a whole number. Now, when you look at this one, of course, this, if you multiply them, you get x squared, negative 3 and 2 minus x minus 6. This is a polynomial of degree 2. Why? You multiply them through and you see x squared is the leading term. So part E, because of the exponent negative 1, no, it's not a function, it's a rational function. And the last one, this is the leading term. Yes, degree is 3. Pretty straightforward, everybody. Graphs of quadratic functions. We call them parabolas. and y equals ax squared opens up if a is positive and down if a is negative. Looking like this when it opens up, looking like this when it opens down. A polynomial of degree 3 such as p of x equals ax cubed plus bx squared plus cx plus d, and again a, the leading coefficient can't be 0. Okay. Looking like that. This is of degree 3 as an example. This is of degree 4 as an example. This is of degree 5 as an example. So f of x equals x to the power of a, where a is a constant, a equals n, where n is a positive integer, meaning 1, 2, 3 to infinity. F of x equals x to the power of n for n equals 1, 2, 3 are polynomials with one term. Y equals x is a line through the origin. M equals 1, the slope. M is the slope. Y equals x squared is a parabola. So we know that. When n is even, that means the degree is even. F of x equals x to the power of n is an even function, and its graph is similar to the parabola y equals x squared, meaning it opens up if the leading coefficient is positive, opens down otherwise, and the concept of an end behavior is coming up. N is odd. F of x equals x to the power of n is an odd function, and its graph is similar to that of y equals x cubed. So graphs of f of x equals x to the power of n for n equals 1, 2, 3, 4, 5. They look something like this. When x is 1, it's y equals x. When x is 2, looking like that. When x equals 3, this is y equals x cubed. And remember, we've discussed elementary functions. We should know the graph. And as you can see, the end behavior, 1 3 quadrant. And this is y equals x to the power of 4. The degree is 4. And this case, degree is 5. Notice these two are sort of similar opening up. These are sort of similar. The first and the third quadrant, that would be the concept of n behavior. As n increases, the graph of y equals x to the power of n becomes flatter near 0 and steeper when absolute value of x is larger than or equal to 1. If x is small, then x squared is smaller, x cubed is even smaller, x to the power of 4 is smaller, and so on. That's why it becomes flat as it gets closer and closer to 1. That's the concept. And so in a matter of comparison, when we look at x to the power of n with various exponents, notice what happens. Of course, 1, 1, and negative 1, 1 is in common, 0, 0 is in common, and it becomes flatter as the exponent becomes larger. The same thing for y equals x cubed versus x to the power of 5. N is being odd, looking like that, even looking like that. If we were to graph by transformation, we would start with x to the power of 5, looks almost like y equals x cubed. So again, look at the exponent. The exponent is odd, and it looks like y equals x cubed. Everybody's familiar with y equals x cubed. So we are going to affect this negative 1. That means multiply by negative 1. So minus x to the power of 5, minus x to the power of 5 makes it flip over with respect to when you put the negative here, it will reflect with respect to the y-axis. However, since this is an odd function, whether you flip it over with respect to the y or x, they look the same. Because, let me explain that one. I want to make sure everybody understands what's going on here. First, let me show you this one. Okay. Because, take a look at what is the reasoning. When you look at this, there are two ways to look at it. You can look at it just the way it is, minus x to the power of 5, or you may look at it as negative x to the power of 5, because the two are identical. Please understand. If you look at it from the point of view y equals minus x to the power of 5, that means it flips over with respect to the x-axis. If you look at it from the point of view of minus x to the power of 5, it flips over with respect to the y-axis. And both of them, they look the same because of the nature of this function. Finally, the effect of one is to take it up one notch. This is 0, 0 goes up to this point 0, 1. So very straightforward, everybody. Well, we start with x to the power of 4, which looks like x squared, roughly. Now, x minus 1, that means move it to the right by 1 unit. So replaced by x minus 1, that means shift it to the right by 1 unit. So 0, 0 goes to 1, 0. Now, 1/2, it shrinks it vertically, so it becomes sluggish and it becomes closer to the x-axis. So multiply by 1/2, compression by a factor of 1/2, compression, or it shrinks like so, becomes closer to the x-axis. Theorem: behavior near a zero multiplicity. The zero of a polynomial f of x are the solutions of the equation f of x equals 0. Equivalently, each real zero is an x-intercept of the graph of f. F of c equals 0, that means there is at least one zero c, and hence by the factor theorem, f of x has a factor of form x minus c. C is the solution of the equation f of x equals 0. If a factor x minus c occurs m times in factorization, then c is the zero of multiplicity m of the polynomial f of x, or a root multiplicity m of the equation f of x equals 0. So the concept of multiplicity is extremely important. If c is a real zero of f of x, of multiplicity m, then f of x has the factor x minus c to the power of m, and the graph of f of x, or f, has an x-intercept c. If m is odd, then x minus c to the power of m changes sign as x increases through c, and hence the graph of f crosses the x-axis at c comma 0. For example, at 0, 0, it crosses it, because to the left of 0 is negative, negative to the power of odd is negative, to the right of 0 is positive, and positive to the power of odd or even makes no difference is positive. If m is even, then x minus c to the power of m does not change sign at c, and hence the graph of f or f of x does not cross the x-axis at c, comma, 0. So what happens is, to the left of this, the number is negative. To the left of this, the number that means the x is positive. But since the exponent is even, a negative number to the power of even and a positive number to the power of even, both of them are positive. That's what happens. Identify the real zeros of a polynomial function and their multiplicity. Look at this one. This graph of a polynomial function. It is smooth and it's continuous, as you can see. However, this is definitely not a graph of a polynomial. You have a corner or sharp corner here, cusp. Sometimes you call it sharp corner. That's fine. There is a difference between the two. We'll discuss that in calculus. There is a gap or a jump. There's a hole. And so that means a discontinuity here and discontinuity here. So it's not a polynomial. So discontinuity and so forth. This one, all of them are continuous. Okay. And as it crosses, it's a graph of a polynomial. As it gets to this point, it crosses the x-axis. Okay. Over here, it touches and returns because this has a multiplicity even. But this x-intercept, and this x-intercept must have multiplicity that would be odd. Turning points. If f is a polynomial function of degree n, then the graph of S has at most n minus 1 turning points. If the graph of a polynomial function has n minus 1 turning points, then the degree of f is at least n. So we want to distinguish between the two concepts, everybody. And of course, the relationship between the two. Find the polynomial of degree 3, whose zeros are -4, -2, and 3. Well, we start with f of x or p of x equals a some multiplier. And for this one, we get x plus 4. For this one, we get x plus 2. For this one, we get x minus 3. I hope everybody is comfortable with the concept. Now, you can multiply them through. I'm going to assume everybody can do that. I don't worry about that. You just do this and then times that. For example, this we should know it's x squared plus 6x plus 8 multiplied by this combined like terms, and that's what you get. Given x minus r to the power of m is a factor of a polynomial, and x minus r to the power of m plus 1 is not a factor of f. R is called a zero of multiplicity m. So if it has m factors but not m plus 1 doesn't go, that has an m multiplicity of m. Given the polynomial, list the zeros and their multiplicities. So very fast, as far as the zeros are +2, -1, +3. Please understand, you set this equal to 0. So this is how you get to +2. So you set x minus 2 equals 0. You get x equals +2. You set x plus 1 equal to 0, you get x negative 1. You set x minus 3 equal to 0, and you get x equals positive 3. Those are the three. Now, what is the multiplicity? Well, this has no exponent. That means exponent 1, multiplicity 1. This has exponent 3, multiplicity 3. This has exponent 4, multiplicity 4. 2 is a 0 of multiplicity 1. The factor x minus 2 has exponent 1. Negative 1 is a 0 of multiplicity 3. The factor x plus 1 has exponent of 3. 3 is a 0 of multiplicity 4. The factor x minus 3 has exponent 4. So pretty straightforward. And behavior. The end behavior of a polynomial function is the behavior of the graph of f of x as x approaches positive infinity or negative infinity. The degree and the leading coefficient of a polynomial function determine the end behavior of the graph where f of x equals a sub n x to the power of n all the way to a sub 0. This will look like a sub n x to the power of n. Again, this is called the leading term. Leading. If you put it in descending order, that means the highest power comes first in the very first term. And the number here, a sub n, is the leading coefficient. So leading coefficient would be a sub n. Let's look at these graphs. This is the graph for a polynomial that has degree larger than or equal to 2, and it's even. The reason we know it's larger than or equal to because look at the end behavior. And f of x goes to infinity as x goes to negative infinity. F of x goes to infinity as x goes to infinity. This one is the same type of function. The difference is it opens down, so the value for this is positive for this case, it's negative for this case. So when x goes to negative infinity, so does y or f of x. Remember, f of x means y. When x goes to infinity, so does y, f of x or y goes to negative infinity. In this case, looking like x cubed, for example, so n is greater than or equal to 3. That's why we put an odd number. A sub n is positive, and in this case, a sub n is negative. So pay attention when a sub n is positive, when a sub n is negative, okay? Remember, for example, y equals x squared opens up, y equals minus x squared opens down. Graphing polynomial using its intercepts and end behavior. It's a very simple process. You find the intercepts. And then you know the end behavior. So if you look at this one, in order for you to know the intercepts, you either have to solve for y or f of x equal to 0, or put it in factored form. Negative 1 is 1 and 2 is another one. So the x-intercept, you set it equal to 0, x equals negative 1 here, x equals positive 2 here. So negative 1, 0. Now negative 1 has a multiplicity 1 because the exponent is 1, and positive 2 or 2, 0 has a multiplicity 2. Negative 1 is a 0 multiplicity 1, m equals 1. The exponent on the factor is 1. Whereas a 2 to 0, the multiplicity, so we're going to go short instead of writing out multiplicity, m is 1, m is 2. The exponent on the factor x minus 3 is what? 2. Now, if you go back to this format, you can see the y-intercept of 4. That means 0, 4. Going back to this one, just look at the leading term. So the end behavior looks like x cubed, which means the first and the third quadrant. That's the meaning of it. We're going to make a summary table by putting those pairs. And another point, if you plug in 3 here or here, you can calculate that's 4. You can always use a couple of points, extra points. So plug in those points. Now, this arrow that you can see represents the fact that it can't cross it. In calculus is used to represent, in this case, either max or mean. This happened to be the mean. This is another point. And now we should know the graph looking like that. So it's very easy to graph. Rough sketch is good enough by hand, of course. With the calculator, you get a more precise answer. As far as the location of this is very straightforward. This you may not know where it is until you use calculus. We discuss that in the next course. Graphing polynomial using its intercept and end behavior. So first of all, we can see that in this case, x equals 0 and x equals 3 are the intercepts. So 0, you set it equal to 0, x equals 0 and 3. So 0, 0, and 3, 0. By the way, 0, 0 is not only an x-intercept, it is also a y-intercept. So we have 0, 0, we have 3, 0. Now, 0, this one has a multiplicity 1, so which means the graph will cross, at that point will cross, whether it goes that way or that way, we may not know, but it crosses it. Whereas here, for number 3 or 3 comma 0, the multiplicity is 2, and because the exponent is 2, and it can't cross. So we show it doesn't cross with this arrow. That means it can't cross. And of course, class, if you multiply them through, by the way, all you have to do, no, it's x cubed. You don't even have to know the rest. Please understand this is x squared times x is x cubed. You don't have to work it out. If you wanted to work it out, you know this is x squared minus 6x plus 9. And if you multiply it by x, you get x cubed minus 6x squared plus 9x. However, as I mentioned, what matters is the leading term. So the end behavior is like x cubed, the first and the last, the third quadrant. So you can always pick up some extra and easy points, extra and easy points. That gives you an idea. So for example, if I plug in 1 here, I get 1 minus 3, negative 2 squared is 4. So 1 gives me 4. If I put 4, 4 minus 3, it gives me also 4. If I put 2, 2 minus 3 negative 1 squared is 1, times 2 is 2. So I can get those easy numbers also. Pairs, I have this one, I have this one, I have this one. Those easy points, and the graph looks like that. And there you have it. Please pay attention to the end behavior of the graph, everybody. Identifying if the graph represents a polynomial function. Indicate the number of zeros and degrees. Clearly, part A is not. Why is that? Take a look. You see a jump, you see discontinuity, therefore it can't be. So it's discontinuous. This one is a nice and smooth curve. Yes, the graph is smooth and continuous. CTS, short for continuous. Now, the number of zeros. Here's one of them, -2. Here's another one, +1. Here's another one, +2. We have 1 and 2 turning points. So the degree must be larger than that by 1. So the degree must be at least 3. It may be more, but it's at least 3. So it has zeros at -2, +1, and 2. With 2 turning points. This is 1 turning point. Turning points refers to max and mean in essence. So we have 2 of them. And the degree must be larger than the turning point at least by 1. So n is greater than or equal to 3. By the way, as you can see, all of those x-intercepts have a multiplicity which is odd because it crosses here, it crosses here, it crosses here. Part C, no, it is not a polynomial. Why not? Look at this point. It's a sharp corner, or they just call it a corner. Look at this one. Sharp corner or just a corner. So the problem is right here. This one, the problem is here and here, okay? So that's not it. But the last one, it's nice and smooth. And that, yes, the graph is a polynomial function. Let's look at the zeros. There is 0. This is one of them at -2. This is another one at +1. And how many turning points? This is 1. This is 2. This is 3. Again, just so you see that for sure. This is 1 turning point. This is another one. And this is the third one. So we have 3 turning points. So the degree must be larger than or equal to 4. You have to add minimum 1. So n is larger than or equal to 4. Identifying the graph of a polynomial function. Which graph could be the graph of f of x equals x to the power 4 plus 5x cubed plus 5x squared minus 5x minus 6? We can figure out by simply getting rid of anything which cannot be. So there are a few points we can make here. Number 1, if you look at this function, what is -6? That's the y-intercept. So f of 0 is -6. The y-intercept is located at 0, minus 6. And since they are below the x-axis, maybe they are, but this is above. Look at this one. The y-intercept takes place here. We may not know what it is, but for sure it's negative. It's not negative, so that's out. You look at the degree is 4. If the degree is 4, we have to have maximum of n minus 1, 4 minus 1 turning points, 3 turning points. So clearly this guy is out. You have 1, 2, 3, 4, 5, too many turning points. Finally, the end behavior is following x to the power of 4. As you know, x to the power of 4 opens up the first and the second quadrant. This opens down and it's out. So there's only one possibility, is this one. Okay, I hope it's clear to everybody. So you can easily see why you would disqualify the rest of it. Example 10, write a polynomial function from its graph. You pay attention to what is given, and that means you start with intercepts. So you see the intercept here, here, and here. And this one, I put the arrow to emphasize this one as it hits the graph, comes back up, has to have a multiplicity even. So we have 3x intercepts. At -2, the multiplicity is even for sure. At 0, 2, it crosses, so the multiplicity must be odd. We look at 1, 2, 3. 1, let me use a different color here. This is 1, 2, 3 extrema, or 3 turning points. So n must be greater than, or n must be greater than or equal to 3 plus 1 or 4. So if we want to go with the minimum number, that has to be 4. So now this one says x minus 0 or x. This one says x minus 2. This one says x plus 2 to the power of 2. And we put a in front. This one because we don't know if we have a coefficient in front or not. But let's find out what happened here. 0 means x minus 0, x. 2 means x minus 2. -2 means x plus 2. It's even. So please understand that this means this one. The next step is to pick an easy point from the graph and plug in and find the missing a. Obviously, -1 comma 6 is given. So what do? You replace the x with -1, f of x, which is y, with 6 to find a. So we are going to say -1, and then -1 minus 2, and then -1 plus 2, and see what happens. Now, this is -3, this is +1, and when you square this +1, and I hope you see that We have a times -1 is minus a times negative 3 is a 3a times 1 remains as 3a. And so you're going to say 6 is 3a. So a must be 2. And now replace that. You're done. F of x therefore becomes a 2x times x minus 2 times x plus 2 quantity squared. So we can easily come up with the equation of the function. Analyze the graph of a polynomial function where f of x is given as 2x minus 1 times 2x plus 1 times x plus 3 squared. And if you multiply them through, you get 4x to the power of 4 plus 24x cubed plus 35x squared minus 6x minus 9. When we say analyze, that means discuss the end behavior, intercepts. When you do that, zeros and multiplicity, maximum number of turning points. Let's do that. And then we can easily graph. Starting with the end behavior. The degree is 4, and leading coefficient is also 4. Even a is 4. So the end behavior looks like x to the power of 4. And for familiarity, remember, we know how x squared looks like, which means the first and the second quadrant. That's the meaning of the end behavior, everybody. Let's discuss the intercepts. You said this one equal to 0, 2x minus 1 equal to 0, x is 1/2, 0. You said this one equal to 0, you get minus 1/2, 0. You get this one equal to 0, you get minus 3, 0. Okay, so again, as you set this one equal to 0. If you do that, this is 0, and x equals 1/2. This is 0, and x equals negative 1/2, and the last one, 3, 0. The y-intercept, you have to set x equal to 0. So it's better and easier to look at this one because actually when you set x equal to 0, it becomes a constant. So the y-intercept is -9, meaning 0, comma -9. So finding the y-intercept is easier to find it from here. If you set x equal to 0 here, it will give you the same answer, but you don't have to do any calculation here. It's just looking at you. Let's discuss zeros and multiplicity. As we look at the exponent here is 1, the exponent is 1, the exponent is 2. So this one and this one, the multiplicity is 1, and therefore they cross the x-axis. So for 1/2, m is 1, it crosses the x-axis. When we say crosses, we mean crossing the x-axis. We get the same situation here. However, this one, the exponent is 2. So 0, -3 has m2. Here's the shorthand notation: 0, -3, m multiplicity 2 does not cross. We mean does not cross the x-axis. So I wrote it here, this to repeat. So put maximum number of turning. N is 4. So it has to have maximum of 4 minus 1 because it's n minus 1. 4 is n minus 1. 3 turning points maximum. So if we put this together, here's the end behavior from the beginning. Here's the 3 x-intercepts. Here's the y-intercept. And it will look like that. So all you have to do, look at the end behavior, x-intercept here. It can't cross. That's why it looks like that. Over here it crosses, over here it crosses. So as it hits this one, it crosses, it is the y-intercept coming back at some point. You may not know whether it comes back at this point or not, but as it crosses this, as it gets to this x-intercept, it has to cross, but it has to come back down to get to this, and then up, looking like that. So you can graph the function easily. Analyze and graph of a polynomial function. Form a polynomial whose degree and zeros are given, don't expand. Degree is 3. Zeros are -2, 0, 4. So I hope you recognize this one as x plus 2, this one as x, this one as x minus 4. Put them together. F of x is x times x plus 2 times x minus 4. We like to put the x first. Please understand. -2, that means x plus 2. +4, that means x minus 4, because you have to set equal to 0. So that's done. This one, zeros of x minus 2, that means x plus 2. With a multiplicity 3, that means the exponent is 3. 1 means x minus 1. Multiplicity 1, that means don't put an exponent. The exponent is 1. So again, this means x plus 2. Let's just, this means x plus 2. And this means this, okay? And this means x minus 1. And this means you don't need an exponent. The exponent is 1. You don't have to. So that's the function. Find a polynomial function, form the graph shown below from. So we just analyze the graph and we can figure out what's going on. Well, we have the x-intercepts. This is located at -2, 0, 0, 0, 3, 0. Those are the x-intercepts. This one crosses, the multiplicity is 1. This one crosses, the multiplicity is also 1. This one doesn't cross, the multiplicity is even, for example, 2. So that's why I put the arrow. And the multiplicity is 1, 1 here. The multiplicity is odd. We are going to go with this smallest one, 1, 1. And of course, look at the turning points would be 1, 2, 3. That means the degree is at least 4. Okay, 1 more. So this would be x plus 2. Okay, this would be x minus 0, or simply x. This would be x minus 3. However, the multiplicity is 2. So we're going to say x times x plus 2 times x minus 3 squared. Again, this one gives you x plus 2. This one gives you x minus 0, which is x. This one gives you x minus 3. Please remember 1, 2, 3. This is the multiplicity, everybody, okay? And so x minus 3, the multiplicity is 2. And notice the degree. This is 1, this is 1, and this one is squared 2. So the degree is 4 here. Okay? We want to go with the minimum degree. Use the intermediate value theorem, short IVT. So we can call it IVT for short. If f of x is a polynomial function or any continuous function, And if for real numbers a and b, the values f of a and f of b are opposite in sign, one is negative, one is positive, then there exists at least one real zero between a and b. So as you can look at this, we're talking about the continuous function between a and b. F of a happen to be something below the x-axis negative, f of b above, and it's positive. So because it's continuous and there is no break, it has to go through 0. If you look at here a and b, same thing, p of a is negative, p of a is negative, p of b is negative. Okay. There happen to be something that as the term happens. Show f of x equals x to the power of 5 minus x cubed minus 1 has a 0 between 1 and 2. Well, if we plug in 1, we get 1 to the power of 5 minus 1 cubed minus 1. I hope you understand that 1 to the power of 5 and 1 cubed both are 1. So it becomes negative 1, and negative 1 is negative, less than 0. Let's look at 2. 2 to the power of 5 minus 2 cubed minus 1. This is 32. This is minus 8. This is minus 1. 23 is positive. F of x is a continuous function, and by IVT, it has at least 1 0 in between. Please understand, why is this continuous? Because it's a polynomial of degree 5. So pretty straightforward, everybody. Again, it's important to know why it's continuous, because it's polynomial with degree 5. That's why. Show p of x equals x cubed minus 2x squared minus x plus 1 has a 0 between 2 and 3. We can evaluate the function at 2 as well as 3. By the way, this is what? A polynomial of degree 3, which makes it continuous. So p of 2, plug in 2. That means 2 cubed minus 2 times 2 squared minus 2 plus 1, and we have 8 minus, I hope you realize 2 squared is 4 times 2 is 8, minus 2 plus 1, it's negative 1. Remember, it's not important that it's negative 1. What matters is that it's negative. Plug in 3. We get 3 cubed, 27. 3 squared is 9, times 2 is 18, minus 3 plus 1. We get 7. Again, it's not important, it's 7. What matters is that it's positive. So we get P of x is continuous because it's polynomial of degree 3, and by IVT it has at least one zero in between, meaning those two numbers. Now, if you were to use a calculator, graphic calculator solution, and I have given you a website here that gives you the table feature in a TI. Okay, so first you put the function in there, whatever the function might be, y1. Okay, and then it graphs it like so. Then the table, and there is no break, but the table feature, creating a numerical table for a function or table. Press Y equals and enter the function. To view the table, go to second table. If you click on graph, you can see that. Now, this part, it says set up your table, go to second table, view the table. It explains how to do it step by step, which means second table set. Take a look. And second table. When you do that, you put those numbers. When you look at 2 and 3, for example, 2 has a negative value, 3 has a positive value, so in between, because of IVT, there has to be a 0 in between. Okay. Here's the picture of how you set up the table. And if you go with 0.001, because we are interested to see somewhere between 2 and 3, if you want to find the 0, it goes with 2.2444. This is the one that you start. You use some starting point of your own choosing. For example, this one, and then 0.001 will be added according to this table, and it will evaluate this. And notice what happens in between. This is negative, and this one is a very small number, is positive, so it's between these two numbers, and it shows it here. This is a negative number. Look at the y coordinates. Negative, negative, negative. This is positive. It's a very small number. 1.1 e minus 4 means, I want to remind you what it means. You should know that this is a scientific notation. It means 1.1 times 10 to the power of minus 4. That's a scientific notation, everybody. And definitely between these two numbers, see how close they are? There is a 0. If you were to find the 0 using a calculator, this is one way to do that. You can get it from the graph as well.